You know, some projects are so big, so outrageously ambitious, that they stop being about engineering and they become something else entirely. They become monuments to sheer, glorious, and let's be honest, completely absurd human stubbornness. And today, we're digging into one of the greatest examples in history, the Channel Tunnel.
The first serious idea for a tunnel connecting Britain and France was floated all the way back in 1802. The thing didn't actually open until 1994. That's almost 200 years between the idea and the ribbon cutting. I guess it just goes to show you that progress, especially when you get politicians involved, can be a little slow.
And what does 2 centuries of arguing and delaying get you? Well, it gets you a final price tag of around $21 billion. That's what happens when you let 2 countries bicker over a construction project for longer than most countries have even existed.
Yeah, that massive bill starts to make a bit more sense when you realize this wasn't some quick, modern project. Nope, this was an ancient fantasy, one that was plagued by centuries of political maneuvering, wild fears, and the simple, terrifying fact that digging under an ocean is an incredibly hard thing to do. I mean, just look at the difference here. The original plan from 1802, it was for horse-drawn carriages, with a man-made island in the middle of the channel just to change the horses. And for literally centuries, the biggest obstacle wasn't the tech. It was British paranoia that Napoleon, or someone else, would use the tunnel to invade. They went from fearing an enemy army to celebrating an economic partnership. It just took them 200 years to get there. And before all the politics and all the money, they had to solve the most basic problem of all. How in the world do you dig a tunnel under a sea without, the sea deciding to come flooding in? And the answer, at first, wasn't about engineering. It was all about geology.
Seriously, just put yourself in their shoes for a second. You're about to send thousands of people and billions of dollars of equipment miles under the seabed. What's the #1 thing keeping you up at night? It's the water, right? An entire ocean just sitting right on top of you, waiting for one wrong move.
So here's the crazy part. The entire project was only possible because of a 1 in a million geological fluke, a magic layer. Deep under the channel, there's this perfect seam of rock called chalk marl. This stuff was the holy grail. It's soft enough for a machine to chew through, it's strong enough not to collapse from the pressure, and, this is the crucial part, it's basically waterproof. Without that specific layer of rock, there's no tunnel.
Period. End of story.
Okay, so nature gave you the perfect waterproof path. Fantastic. Now you just need the tool to carve it out. And you can't just pop down to the hardware store for this one. You need a whole fleet of custom-built, giant, robotic monster worms.
They didn't just build one of these things, they built 11. 11 gigantic tunnel boring machines, or TBMs. 6 started digging from the UK, 5 started from France. And they all headed toward each other in the pitch black, hundreds of feet beneath the waves. Honestly, these machines are the real heroes of this story.
And don't just picture a simple drill. Each one of these TBMs was basically a moving factory. At the very front, a massive cutting head would grind away the chalk. At the same time, a huge conveyor belt would carry all the rubble all the way back out of the tunnel. And while that was happening, a robotic arm was grabbing huge concrete segments and building the tunnel wall right behind it. Then, hydraulic jacks would push off the new wall to move the whole machine forward. It digs, it cleans up its own mess, and it builds the tunnel as it goes. Absolutely incredible.
And here is my absolute favorite part of this whole story. After all that incredible, high-tech engineering, when a couple of the British machines finished their jobs, the accountants did the math, and they figured out that it would actually cost more to take them apart and bring them to the surface than to just leave them there. So they steered them off to the side, into the rock, and just buried them forever. Those multi-million-dollar robots are still down there right now.
So the giant robot worms are chewing through the rock. But that brings us to the next uh-oh moment. You've got 2 teams in 2 different countries digging toward each other under the sea. You can't see them, you can't hear them. How do you make sure they actually meet in the middle?
I mean, really think about the stakes here. There's no GPS, you're miles underground. If your calculations are off by even a tiny fraction of a degree at the start, you could miss each other by hundreds of feet in the middle. That would be billions of dollars wasted on the world's 2 most expensive dead-end roads. The pressure on those surveyors must have been just immense.
So, how'd they do? Well, after years of digging across dozens of miles, the 2 sides finally met.
And when they broke through, the final horizontal difference between the British tunnel and the French tunnel was just 358 millimeters. That is barely wider than a school ruler.
But wait, it gets even crazier. That was the side-to-side alignment. What about the vertical alignment, the up and down? They were off by only 58 millimeters. That's about 2 inches. The level of precision is it's staggering. It's truly one of the greatest surveying feats in all of human history.
And all of that mind-bending math led to this one iconic moment. On October 30th, 1990, they drilled a tiny little hole through the last wall of rock separating the two sides. A French worker and a British worker reached through and shook hands. Yeah, it was a huge symbolic moment. But let's be real. It was the climax of an incredibly difficult, stressful, and ridiculously expensive math problem.
Okay, so the tunnel's dug. The two sides have met. Champagne for everyone, right? We're done? Well, not so fast. Turns out, after they had defeated the sea, the rock, and the laws of probability, they had one final boss to fight. A totally unexpected enemy. The air inside the tunnel.
So the problem is something called the piston effect. And it's pretty easy to picture. Imagine a syringe. The tunnel is the tube, and the high-speed train is the plunger. When you push a plunger into a syringe, it compresses the air and it's hard to push, right? Now imagine that plunger is a train trying to go hundreds of miles an hour. All that trapped air in front creates this massive wall of resistance, slowing the train down and wasting just a colossal amount of energy. So after 200 years of dreaming and $21 billion, they had accidentally built the world's most inefficient train cannon. The problem was so bad that high-speed travel was basically impossible. So, oops. What do you do now?
Well, the solution was beautiful. It was simple, it was elegant, and it was totally ingenious. And it all came down to this number, 194.
See, the genius part is that they didn't just build one tunnel, they built two main ones running side by side. So the engineers went back and just poked holes between them. They carved out 194 of these smaller passages connecting the two tunnels. Now, when a train comes roaring through and builds up that wall of air, the air just says, nope, see ya, and escapes through the nearest duct into the other empty tunnel. The pressure just vanishes. Problem solved.
So when you put it all together, the 2-century wait, the absurd cost, the geological miracle, the buried robots, the perfect math, the air cannon problem, what's the final verdict on this thing? What is its legacy?
Well, the final numbers are just plain staggering. 31.5 miles long, with 23.5 of those miles under the sea, which is still the longest underwater tunnel in the world. It took about 13,000 people 6 straight years of non-stop work to build it. No matter how you feel about the cost, you just can't deny the sheer scale of the achievement.
So in the end, what's the real takeaway here? Is the Channel Tunnel a pure triumph of engineering that reconnected an island to its continent for the first time since the Ice Age? Or is it a $21 billion monument to 2 centuries of political bickering and just pure, uncut stubbornness? You know what? I think the answer is probably both.